Today, we're going to try to understand database normalization. What is database normalization? Why is it important? What are its costs? When do you need it? When do you not need it? And how does it help us understand the differences between SQL and NoSQL databases? Let's dive right in. What is database normalization? Let's start with a practical example. Imagine that the owner of a second-hand bookstore has contacted you. She's asked you to help set up a Notion database to track which books she has in store so she can sell the books on her website. Now think about it for 2 seconds. What information needs to be on the page and what do we need to store in the database? Well, the likely candidates would be the book title, obviously, the edition, the publisher, the publication date, whether the book is a hardback or a paperback, the physical state of the book, obviously, the selling price, the author's name, and maybe also the author's bio. A simple first version of the database might be one table that lists all these fields. So let's start entering our data. We have Douglas Adams' The Hitchhiker's Guide to the Galaxy, William Shakespeare's Romeo and Juliet, and Tolkien's The Hobbit. Now we have Douglas Adams' The Long Dark Tea Time of the Soul, Tolkien's Silmarillion, and Shakespeare's Merchant of Venice. And now we start to see the problems. You see, we're copy-pasting the author's bio between different lines or rows, to use the proper database term. Very quickly, when you start working as a developer, you realize that something somewhere has gone wrong when you copy-paste data or code. So how can we organize things better? Well, that brings us back to database normalization. Database normalization was invented in 1970, and at the time, it was created because storage was expensive. But at the highest level, database normalization is about structuring data in a database to reduce redundancy. Like I said, the goal was to minimize the disk space that was used. But wait a second. Today, half a century later, we're storing much bigger data than that text, like video and images. So we don't need to minimize space quite as much. So is database normalization still relevant today? Well, we've previously discussed the ACID rules: atomicity, consistency, isolation, and durability. These rules help databases limit bugs when creating transactions. Now, durability isn't really relevant when discussing normalization, but the other three are, so let's go over them briefly. Atomicity means that a database transaction works as a whole. You can't have half a database transaction written in the database. Isolation means that the transactions function independently. You can't have two transactions that are running simultaneously on the same data. And consistency means our transaction follows database constraints, or it fails. Now, let's get back to our books database example. Let's say, for example, that we need to change an author's bio because they've passed away. We would need to go through every single book in our database by this author and edit the bio. We would need to change the same data at many different places. But the more data we need to change, the more complex the database transaction is, and the harder it becomes for our changes to be atomic, isolated, and consistent. Every information quantum, every little piece of information should be stored in one place only. That is what database normalization is all about. So let's refactor our database, shall we? The obvious solution, and the one you've probably come up with if you've ever used any SQL database, is to create an author table. This will have the author's name and bio, and now in our books table, we reference the relevant entry in the author's table instead of storing the author's information directly within the books table. So now, when we need to change the author's bio, we only need to change it in one place. In my example, I only focused on one type of data duplication, but there are others. The first one is between rows. If two rows contain precisely the same data, well, we only need one row. We've already talked about isolating common data between rows, but there's another form of duplication, which I've seen cause bugs and confusion. You see, I made a mistake when creating the author's table. Did you spot it? Well, let's say we need to search for the author by last name. The problem is that I grouped the author's first and last names together in the same field. Technically speaking, this isn't really a normalization problem. It's just bad practice to do that because splitting the data afterwards is a pain. So let's add the first name, middle name, and last name fields to the database. And now we do have a normalization problem. The name field is the result of concatenating the other name fields together. So data is duplicated between columns this time. And that will also create bugs. Why? When you have a calculated field, every time you change a field that's part of that calculation, you also need to remember to change the calculated field. relying on developers remembering this quirk of database design, of the way you've set up the database every time they code, is just asking for trouble. I've had to solve several bugs recently caused by this exact defect in our database structure. And once again, the more fields you need to change, the harder it is to enforce atomicity, isolation, and consistency. In short, duplicated data causes bugs and complicates ACID compliance. Database normalization aims to reduce duplicate data. However, it's also worth noting that database normalization is a constraint. It adds both complexity and cost. Why? Well, data is split over several tables, and there are no calculated fields. You need to build the data before you can use it. That means that there are times when it makes sense to denormalize. For example, at work, when I needed to calculate the revenue that was generated, I needed to join the orders, the clients, the order contents, the article tax rules, and so on. And that meant that generating a monthly report could take a day or two. It was long, it was tedious, it was error-prone. So what was the solution? Well, we denormalized. We created a reports table where we pre-calculate and denormalize the data. The table now contains all the information that we need for the report. And now we're able to generate reports in near real time. And you know what? The drawbacks of denormalization don't apply here, because in the reports table, each row is intended to be written once only and then read a lot. It isn't used in database transactions at all, other than the one used to write it initially. In other terms, there are use cases where it makes sense to break the rules and not to normalize data, because not everything is a transaction. And that's the guiding principle behind NoSQL databases, the selective breaking of rules, be it normalization or ACID rules, which I've explained here. And that's probably the best way to understand the difference between NoSQL and SQL databases, which we can explore together in this video. I'll see you there.